So last class we were doing with the conservancy or how to do the waste disposal. Uh, so we were doing with the disposal of the refuse, the different methods to be followed, dumping, which is not at all a sanitary method, and then the control tipping, in which we make it layer by layer. And then we saw according to the area that is available, there could be a trench method, a ramp method, and also the area method. But the problem with area method is there won't be any excavated earth to cover over that dumped waste. So we have to bring the earth or the sand to cover it from somewhere else. So that is the only negative with the area method. And principle, be it area method, ramp or trench, or even the dumping, the principle is same, because when we put it together or dump together and layer it differently and also cover it, after a few days, because of the thermal changes or the action of the bacteria, the temperature increases, and that temperature will be killing all the organisms, all the bacterias. And after few days, like 2 to 3 weeks, it will be cooling down, and then it will be converted into an organic matter. And we saw incineration, especially when there are no area. In Singapore, the main method is incineration. They take the waste material to a island where there is no inhabitant, and then they incinerate over there. The best method to dispose the hospital refuse or the hospital waste will be doing the incineration. So, oh, did I take this incineration? I'm not sure. Did I take, or I stopped with incineration? Huh? I think I did only this much, isn't it? I have to do incineration, I guess.
Yeah, yes.
Yes, okay. So incineration, it is burning in a high scale manner. So refuse can be disposed of hygienically by burning or incineration. It is the method of choice where suitable land is not available when we don't have enough area. Like in Singapore, you know how your neighboring country is so dense, and there is no area available. So in that case, when there is no area available to dump it or do the control tipping, then the best method is incineration. Hospital refuse, which is particularly dangerous, is best disposed of by incineration, because the hospital thing, there may be what is that? The clothes, which will be having the blood or the pus, or any discharge from the patient, and also the use syringes. So they are easily transmitting any kind of disease. So they're particularly very dangerous. So it is better to get it disposed of by incineration. Incineration is practiced in several of the industrialized countries, particularly in large cities, due to lack of suitable land. So I have kept a lot of videos for you to watch. I think we'll watch just one from this. Uh, the other videos, maybe you can watch it later. So we are seeing the YouTube page now. Are you all?
Yeah, seeing the screen, yes.
The waste that we have here is just mixture of all types of waste. You don't have to do a segregation when it comes to the Azure. Even you look at this one, it's just a power bank battery. We can just drop it in. We can just put it into the Azure. Used plastics, cans, boxes, your general municipal waste from your household. Everyday waste, easily treated. You don't have to do any sorting. You put in a power bank, you can go. You put in a spray can canister, you can just go. All right. So all this can go into the Azure easily without sorting, without any segregations. And to operate the Azure is very easy. Ragu? So all you need to do is just shove everything in, just push everything. The Azure now is operating about 400 to 500 degrees C. And as you continue to use it, it will build up to 700. Next one goes up to 1100 degrees C maximum. So once the chamber door is closed, it will be a closed loop system. There's no other emissions coming out of it. So the process for this to take place is about 30 to 60 minutes. Everything will be disintegrated into ash. What happened in the chamber is baking and drying at ultra high temperature, right? So there's no fire, there's no combustion in this system. We are not burning. It's just heating and drying, right? So when you do not burn, there's a very different chemical reaction as compared to incinerators or WTE. So what we are availing here is a very clean, cost-efficient, and practical solution to treat waste, to dispose waste without fuel, without diesel, without gas, without any petrol. It's going to be self-generated, the heat, and will self-contain and continuously be treating the waste without external fuel energy. Just for demonstration's sake, this is untreated smoke, right? This is very bad. So from this untreated smoke, it goes through the proprietary water scrubber system, carbon filtration system, and then it goes through a second stage of the water scrubber system and the filtration system. So after the two filtration system, we release full compliance vapor. So we release only vapor after all the filtration system, and the vapor is in the form of mild alkaline, a pH of 8.5. So it's not acidic and it's only vapor. The fume that comes out is 100% vapor. It's not smoke. For our 2-ton solar, it's 70% of vapor, 30% of smoke. And our emissions are in full compliance to the US EPA standards. Our suppression system is easily more than 99% effectiveness against the allowable limits. Okay, we have 3 different models of the Azure, being the 2-ton solar, 3.5-ton electric smokeless, and 4-ton electric smokeless. So the 2-ton solar it can be deployed off-grid on islands, rural areas, kampong, villages. For the 2.5-ton and 4-ton electric smokeless, is more suitable for urban setting where it releases only vapor. And the power, the electricity that is used by the electric unit is not for the heat treatment process. The electricity here is for the aeration system and for the water scrubber system. And the power that we consume from the Azure is, on the average, is not more than 4 kilowatt per hour, which is very much the same as your 1.5 horse aircon at home.
Cuba bayangkan, kita dah meninggal tu.
Falah, takut dah falah. Bayangkan.
So when you see fire, means the temperature is really high and there's a contact of oxygen. Otherwise, it's a closed loop system. oxygen will be exhausted inside. What we are doing now is currently relocation of waste from one location to another location, and finally at the landfill or at the incinerator. In this case, everything that comes here, ends here, stop here. From the ash itself, there's no secondary discharge. There's no secondary contamination. Everything stops here. Even the asher, the consumables that is used to maintain the asher, it will be self-treated in the system. It will not be sent somewhere else. And the byproduct of the asher, which is the ash down here, can be used as fertilizers, or you can use into make sand bricks. This thing is green and environmental friendly. Even the surrounding of the working area of this place is clean. We have tested the environment air quality within this working area using a system. The air quality parameters that includes CO, CO2, PM 2.5, NOx and SOx, it's all in the green zone. It means that this is a place that is suitable and safe for the workers to work. There's no smell, very minimal smell. There's no water, there's no wastewater around here. There's no bacteria or old rodents or flies flying, maggots flying around here, because waste are treated at source, as early as source. Whatever that comes, we just put it into the ashes and treat it. Imagine this is being placed at condominiums, shopping malls, airports, low-cost apartments, or taman perumahan. Waste are treated at source rather than being accumulated and be transferred to one location to another location. In our case, in the KL scenario, will be from the household community to the transfer station, and when the transfer station, then you go to the landfill. In terms of concentration, this is 2.5 ton electric smokeless. So on a daily basis, we are treating between 2.5 tons to 3 tons. An incinerator, a last year incinerator ranges between 500 tons to 1,000 tons. All right. In terms of emission temperature, an incinerator will release its emission at the temperature between 150 degrees C to 180 degrees C. For ours, we release at below 48 degrees C. So in terms of temperature, it doesn't impact the environment. In terms of pollutants, like I mentioned earlier, our suppression system is up to 99% efficiency. For instance, the most pressing matters will be dioxin and furan. Allowable limits for dioxin and furan based on the US EPA standards is 0.1 mg per meter cube. This asher releases 0.0014, which is about 99% lower than the allowable limits. In terms of CO, carbon monoxide, allowable limits based on the US EPA standards is 50 mg per meter cube. Our system releases 0.2 mg per meter cube. That's about 95% lower than the allowable limits. So we have tested, this is not a concept, this is not a trial. We are in 13 countries, we have supplied more than 60 units.
Yeah, so coming back, I hope you enjoyed the video. How was it?
Yeah, good info, because I never think of that. It's already in Malaysia.
Yeah, seriously, because I earlier had put one video for Farha when I was taking for Farha, and it was comparatively longer. So when I was doing the PPT for today, I thought, okay, let I see. And when I checked it, it was 8 years before. The video was from 8 years before. Then I thought, okay, I'll see any updated videos are there or not. And then I again Googled in the YouTube and I found this one, and I was like, wonderful. This is something that has to be adopted more and more, because even later now we'll see that the waste we have been doing this composting, this tipping, and then yeah, we are getting a reclaiming land. We are having the humus, but the same thing, if we can get it from a machine without causing any pollution, So that is very best thing. So that is why I put that video for you to watch. And all others are different waste disposal, the thing that may be happening now, so that you can watch. But this one was very nice. I wish that it becomes more flourished all over the world. Actually, it seems to be very environmental friendly. Okay, so moving on. The next one is composting. In composting, it is similar to control tipping, but the thing what is different over here is we are going to dispose the night soil also. Along with the refuse, the garbage, we are going to dispose the night soil. Night soil means the human feces. So in the control tipping, we were not doing that. In the dumping also, we were not doing, it was just the dumping of the refuse, but not the feces. But here in composting, we are going to dispose the refuse and also the night soil or the sludge. When I say human feces, it would be like mostly in rural areas where the people might be still going for open defecation in that condition, or when there is a public sewerage system. So in the public sewerage system, we will go in the later slides, we'll see the public sewerage system. So its after product will be the sludge, will be having some night soil in it, because it is connected to each house, the flats everywhere, the residential areas. So in that, the sludge that will be having some night soil into it or the human feces. So then how to dispose that? That is the method of composting. So it is a process of nature whereby organic matter breaks down under bacterial action, resulting in the formation of relatively stable humus-like material, and that we call as the compost, which has considerable manurial value for the soil. So the same thing that what is happening in the composting and the dumping, the principle is being the same. Here also you see that the heat is produced during composting, and it will be 60 degrees Celsius or higher over a period of several days. And this high temperature will be destroying all the eggs, larvae of flies, weed seeds, pathogenic agents, and all the organism, the ova, the cyst that might be present in the night soil. Everything will be decomposed, and the byproduct will be mainly carbon dioxide, water, and heat. The end product, the compost, it contains few or no disease producing organism. It is a good soil builder, and it contains small amount of major plant nutrients such as nitrates and phosphates, especially the ammoniacal compounds. It will be decomposed to nitrates and phosphates. So even that will be present in that compost. So we can use it as a manure also. So that is the process of composting, very much similar to control tipping, the principle. But the only thing is here, even the night soil is being treated or it is being converted into composting. So we have two methods of composting. One is the Bangalore method, it is called as anaerobic method, or here oxygen is not utilized. And another one is mechanical composting, almost that is happening in a factory. Uh, uh, and this is aerobic method, or air is being used. So the mechanical composting is being done now in countries like Holland, Germany, Switzerland, and Israel. So in the Bangalore method, they are going to prepare some trenches. You can see the measurements. I'm not going through those measurements, but these measurements, it depends upon the amount of refuse and night soil to be disposed of. Depth greater than 90 centimeter or 3 feet are not recommended because of slow decomposition. So even if you don't remember these values, these depth, breadth, and also the height, but remember this value, the 90 centimeter or the 3 feet, because this process is going to take place in a longer time, a slow decomposition, so better don't go. And also because the night soil is mixed, it should be kept away from the city limits. It should be in a minimum, or the distance that has been told to keep up from a water body, the source of water, that also should be maintained. So the pits should not be should be located not less than 800 meter or half mile from the city limits. So this method, the Bangalore method, usually takes place in a heavily dense city area, and it should be away from the city limits. Like minimum of 800 meter or half a mile should be away. And also when we go for the depth, it shouldn't go beyond 90 centimeter or 3 feet. It will be still another process of layering. So you can see the layering. First, a layer of refuse about 15 centimeter is spread at the bottom of the trench. So first they do go for the trenching, and then the first layer will be the refuse. Of 15 centimeter, doesn't matter the value as of now, it depends. And over to this, they put a layer of night soil or that sludge that is coming out, corresponding to a thickness of 5 centimeter. Then alternate the layers. So one layer there will be refuse, then another layer of night soil. They keep it in layer by layer till the heap rises to 30 centimeter or 1 feet above the ground level. And the top layer should be always that of the refuse, not the night soil. So the underneath layer, the first underneath layer, that is also refuse, and also the topmost layer should also be refuse. And the refuse is actually having more thicker layer than compared to the night soil. So it is kept in alternate way, and then when it reaches to that level 30 centimeter above the ground level, then close it off. It is covered with the excavated earth. If properly laid, a man's leg will not sink when walking over the compost mass. And the same principle is happening. Within 7 days, the bacterial action is going to take place, which produces heat over to 60 degrees Celsius. And that will be converted into the compost mass. This heat will be persisting for 2 to 3 weeks. It then decomposes the refuse and the night soil, and then all the pathogenic organisms will be destroyed, completely converting that waste, the refuse and the night soil into a high manure compost. At the end of 4 to 6 months, decomposition is complete, and the resulting manure will be odorless, innocuous material of high manurial value ready for application to the land. However, the Environmental Hygiene Committee did not recommend composting by municipalities with a population of over 100,000. Bigger municipalities should install underground sewers to transport human excreta. So this committee in 1949 itself, they told it is possible for the municipalities which is less than 100,000 population, and the bigger population, they should have underground sewers to deposit that human excreta. I don't know which was this one. Okay, this is each video that is showing the process of composting, the methods, this one, the Bangalore method, and also the mechanical. Maybe mechanical we watch. Because mechanical composting, this one, the anaerobic method or the Bangalore method, when the area is available, we are doing it manually. But in mechanical, it is almost like we take this refuse and the night soil, and it is being treated to produce a manure in some factories. So ASHO was not exactly composting, or maybe it can be considered as a composting, but he didn't say anything about the night soil. He just told anything can go into it, even the power bank. I'm not sure, but in case of mechanical composting, the compost is literally manufactured on a large scale by processing raw materials and turning out to a finished product. The refuse is first cleared of salvageable materials such as rags, bones, metal, glass, and items which are likely to interfere with the grinding operation. So definitely not according to the video that we saw. So they first remove all the things which are going to interfere with the grinding, and then they're going to grind it or pulverize to reduce the size of the article to less than 2 inches. The pulverized refuse is then mixed with sewage. The sewage means the sludge that is coming from the public sewerage, and then it is incubated in a rotating machine. It is put in a rotating machine and then incubated. And during incubation, so many things are kept in control, and that is carbon-nitrogen ratio, temperature, moisture, pH, and also aeration. So they are utilizing oxygen during the process of this incubation. So that is why mechanical composting is called as aerobic method. In case of Bangalore method, we were just layering it off and leaving it. It was the anaerobic bacteria that was breaking it off, the temperature being rising, everything. The anaerobic method was happening. But in case of mechanical composting, because it is happening in some factory, there is no bacteria to do the decomposition. So that is being done mechanically, and then during that process of incubation they use the oxygen. So that is why the aeration comes, and then it becomes a aerobic method. The entire process of composting is complete within 4 to 6 weeks. I think this video we will be seeing. Oh, wait.
In our
Okay,
previous
the
video,
method, I think.
we discussed the process of composting and the basics of how it can be done manually as well as mechanically. Now, there are several different ways of composting, among which the Bangalore method is one. Bangalore method is an important question from your exam point of view, so let's try to understand this technique better. To begin with, this is an anaerobic procedure developed by the ICAR, or the Indian Council of Agricultural Research at the Indian Institute of Science, situated in Bangalore, and hence the name. So, what exactly is done in Bangalore method? In the Bangalore method, we first dig pits or trenches depending upon the amount of refuse and night soil to be disposed of. To avoid slow decomposition, avoid trenches having a depth of greater than 3 feet. You might be wondering, can these pits be dug anywhere? Well, this technique specifies that the trenches need to be located at least 800 meters away from the city limits. So, what next after digging the pits? As you can see here, first, a layer of refuse is spread at the bottom, over which a layer of night soil is added. Night soil is a term used to refer to human excrement and other bodily waste that is collected from households and used as a fertilizer for crops. The term has its roots in a time where human waste was collected at night and transported to fields for use as fertilizer during the day. Following this, alternate layers of refuse and night soil are added till the heap rises 1 foot above the ground level. Always remember, the top layer of this heap should be of refuse, which is at least 9 inches in thickness. This heap is then covered with excavated earth and then compacted to prevent fly breeding, entry of rainwater into the pit, and for conservation of the released energy. Due to the bacterial action, within 7 days, considerable heat of over 600 degrees Celsius is generated in the compost mass. This intense heat will persist for over 2 to 3 weeks, thus leading to the decomposition of the waste. This is the reason why this procedure, alongside being known as the Bangalore method, is also known as a hot fermentation process. By the end of 6 months, the decomposition is complete, and the resulting material is a well-decomposed, odorless material with good manurial value. To summarize, This procedure is carried out by digging trenches at least 800 meters away from the city bounds, and alternate layers of refuse and night soil are filled in, with the top layer always being the refuse. The heat of over 600 degrees gets generated within a week, and by the end of 6 months, we have our decomposed material ready, which can also be used as good quality manure. This was all for this video. Hope you have a better understanding of
Sorry. When I was sharing, I did the Bangalore method. Then is the mechanical thing. I think you may watch it later. We'll go to the next one because there is another video also which I want you to see. So mechanical composting, I made a mistake. Okay, I shared this one. Actually, it should have been this one. So you can watch it later. We go to the last method of refuse disposal, that is manure pits. I think I have not shared. Are you seeing the PPT now?
Yes.
Okay.
Manure pits.
Okay, so the last method will be the manure pits. And manure pits, it's like that is happening in a rural area in a single individual house where they don't have any other methods of this composting or something. Yeah, it is composting, but in a small scale. In front of each house, we can do. So, like a pit, they are going to make it, not in a very wide, large area. So in rural areas, there is no system for collection and disposal of refuse. It is thrown around the house indiscriminately, that resulting in gross soil pollution. So the problem of refuse disposal in rural areas can be solved by digging manure pits by the individual householders. The garbage, cattle dung, straw and leaves should be dumped into the manure pits and covered with earth after each day's dumping. So like that, in each individual house in a rural area where they have space, they can go for this method. So it ideally should have, I mean, after putting every day the refuse that has been produced that day, then cover it with some earth, then reuse it next day. So two such pits will be needed. When one is closed, the other should be in use. So once one of the pit is getting filled up, use the second one. And by this time, the principle is like that. By the time the second one is getting filled up, the first pit, it should be getting decomposed, and to reuse it for some composting purpose or for agriculture purpose, we could use it. In 5 to 6 months, the refuse is converted into manure, which can be returned to the field. This method of refuse disposal is effective and relatively simple in rural communities. Refuse disposal cannot be solved without the public education. You know that, because people, they have very little interest in cleanliness outside their homes. Once the waste bin or the dustbin have been dumped to the common area, then we are not bothered what is happening outside. What they told is true. So public education is very much required. Many municipalities and corporation, they usually go for the cheapest solution, especially in regard to refuse disposal. And maybe in one of the earlier PowerPoint we were doing, like in the water system, at that time there was a sentence, I don't know whether you remember now. There was a sentence in one of the slides that even in Malaysia, they gave more importance, or they were ready to, the government were ready to give more money for the supply of safe water, and they were not ready, or they gave very less amount for the sewerage system. So the sewerage system, the public sewerage system, it didn't come up to the mark, because the amount they were ready to spend on that was very less. The main priority was supply of safe water. So that sentence was there, but it is usually, I mean, that was not just of Malaysia, but it is a generalized thing that people will be giving more importance to supply water, because that is one of the most useful or the indispensable thing that we need for the existence of life. And when compared to safe water, when we have to set the priorities, a community have to be given fresh water or a safe water or the waste disposal, uh, both are equally important. But then if the resources are very less and we are asked to prioritize, the little bit priority will be going to the safe and wholesome water. So therefore, so that it is a generalized thing that people, the municipalities, the corporation, they will be going for the cheapest method. So what is needed is public education by all the means. We can use pamphlets, newspapers, broadcasting, films, etc. And sometimes even laws, enforcement of laws may be necessary, like don't dispose litter in the public, like that it is required. So any method of refuse disposal, we need the cooperation from the public. Now we go to, after doing with the refuse disposal, we'll go to the excreta disposal. So the public health importance, you know, what is the importance of excreta being disposed properly? Because of the flies, the insects, their nature to sit in the fecal matter and then to jump or hop off to the exposed food and then transmitting a lot of diseases. And as we already learned, the human excreta will be containing billions of pathogens. So it is a source of infection and an important cause of environmental pollution. Soil pollution, water pollution can happen. So it is the society's responsible for its safe removal and disposal so that it does not constitute a threat to the public health. So sanitation, its definition according to World Health Organization is the infrastructures, facilities or services provided for protection as well as safe management of human excreta emanating from the toilet via its handling, storage and treatment on-site or off-site by conveying same waste safely to the end use or disposal. That was the definition given by WHO in 2018. You don't have to by heart it, but it just shows the sanitation. It's not just the process, it includes even the infrastructure, the facilities and the services, and also from the toilet, how it is being handled, stored and also treated. So everything, the whole process and the infrastructures involved, everything comes under the definition that was put forward by WHO in 2018 for the sanitation. The health hazards for improper excreta disposal is soil pollution, water pollution, propagation of flies. They will be seen more if the food or the soil, the night soil is being disposed in open, and also contamination of food. So that can result in typhoid, paratyphoid, dysentery, diarrhea, cholera, hookworm disease, ascariasis, viral hepatitis, and similar intestinal infections or parasitic infestations. So these diseases are not only a burden on the community in terms of sickness or mortality and a low expectation of life, but a basic deterrent to social and economic progress. This we have already discussed, because if a community is not healthy, if there is not proper solid waste disposal, then that area will be filled with communicable diseases. So the communicable diseases will be more affecting actually the younger generation. So in a longer run, people will be having morbidity and mortality in such a rate, and that is going to affect the social and economic development of the country. So we can see this is like a vicious cycle. Like if it is a developed country, they will be having better mode of solid waste disposal, and their communicable diseases are all less. The mortality, morbidity from these communicable diseases are very less. They are socio-economically in a higher position. But when we come to the poor countries where the socio-economic level is already low, then they don't have much money or resources to spend it for the waste disposal. And that is going to result in communicable diseases, which will affect the population, the increasing the morbidity and mortality. Then they won't be healthy enough to work or be productive in their life, resulting in still lowering of the socioeconomic standard of that country. So it's like a vicious cycle. Proper disposal of human excreta, therefore, is a fundamental environmental health service. And methods of excreta disposal. how we need to dispose the excreta. So there can be unsewered areas or sewered areas. Unsewered where there is no public system, public sewerage system. That is called as the unsewered areas. So there are three types over there. The first one is service type latrines, or it is also called as conservancy type. The second one is non-service type or the sanitary latrines. And underneath that, we have the borehole latrine, dugwell or pit latrine, the water seal type of latrines, PRI or RCA type or Sulabh Shauchalaya. This is mainly the type which used to be, I mean, it's still in use in India. Then the principle of septic tank. Then latrines suitable for camps and also for temporary use. We can use a shallow trench latrine or deep trench latrine. It depends upon the camp, number of people attending the camp, and also for how many days the camp will be going on. So if it is like a 1 or 2 day camp and only 10, 15 or 20 people are there, we can go for a shallow trench. But if the number is more or the days are more, then we go for a deep trench latrine. That principle is like simply they are going to dig a trench, actually shallow or deep. It depends upon the population or the number of people attending the camp, and also the duration. Then pit latrines or borehole latrines, that are the ones suitable for camps and temporary use. And in case of seaward one, there will be a public water carriage system and then its treatment. So they will be having a primary treatment, a secondary treatment, and also after this treatment, what you do with that, the other methods to be done in seaward areas. So the thing with non-seaward, the sanitation chain, how it is meant is by this figure, you can see the user interface, the excreta, which will be stored for a while, and then it is emptied or transported to a public area where it is getting treated. And then that will be sent for the composting and use of the disposal of it. That is happening in non-seaward sanitation chain. And sanitation chain in seaward areas where there is a public system, from the utilization, I mean the use of the toilet within the house, then there will be a storage area or the containment tank. And from there, it may be conveyed via the motor vehicles or something for treatment, where it is treated, and then the sludge can be treated as a soil conditioner or a solid fuel or building materials. So in case of non-sewered area, in some houses, like in a small individual houses, we can go for the method of septic tank. Then the connection is not made with the public sewage system. But if it is like in Malaysia, a bigger flat or a residential area of Kuala Lumpur, where the people are not having individual houses and they don't have this facility of the septic tank, then there should be some mode of container, and then this will be taken to some factory where it is getting treated. Then it is being composed, made than the compost. So starting with the unsewered type, the first one is the service type or the conservancy system. So this used to be back the method like many years back, not many years, maybe century back, I think. At that time, there was no the concept of septic tank or even any mode of disposal. Actually, people will be going to toilet, and the waste will be collected in some bucket. This used to be the method. So you can just imagine how unsightly it is, how smelly it would be. And every day night, there are a section of people who are going to come to take this pail or the bucket of human feces from each household, and they will be going and dumping it. So this was the method that was done many years ago. Now, I hope it is not being done anywhere in the world. Though I'm not that sure of. The collection and removal of night soil from bucket or pail latrines by human agency is called the service type or conservancy system. When we were saying the YouTube video of the Bangalore method, you might have seen that conservancy or that method that came from the night soil. Why the human feces is called as night soil? You might have noticed in that video the name origin, and they have told it was because of this method. In India, back many years, maybe my grandfather's time and all, this was the method. It was collected in some pail, and then people will be coming and carrying it and putting it for dumping it in the night time. So because it was collected in the night, the human excreta was called as the night soil, which is still continued. So the night soil is transported in night soil carts to the place of final disposal. It can be either disposed by composting or buried in shallow trenches. But this method will be perpetuating the disease cycle of fecal-borne diseases in the community. Because if it is properly disposed, okay, fine. But if it is not properly disposed, they are just dumping or something, then there is a vicious cycle. This food feces diseases are very common going to happen. And also you should understand that at that time, these people, they were considered to be very filthy, and they didn't have the protection like gloves and all or any other sanitary wares while they are doing this job. They had to be whatever they were wearing, they had to supposed to do this work in that manner only. So even these people who were dealing with the night soil, they were exposed to a lot of diseases. So this cycle that was perpetuating at that time. And the night soil, if exposed to flies, there is always the possibility of water and soil pollution. But nowadays, it is not the human labor for the collection of night soil is not consistent with human dignity and is no longer pardonable. The committee, the Environmental Hygiene Committee in 1949, therefore recommended that in unsewered area, the service latrines means a person, a human being is used for carrying that feces from the disposal area or from the toilet to another disposal area. A human person is used in service. That is why it is called as service latrines. Someone is serving or servicing over there. And in 1949 itself, it was decided that it should be replaced by sanitary latrines. So understand that term, the service latrine and the sanitary latrines. In service latrine, it is some human being that is being utilized to carry this pail of or the bucket of human excreta to an area of disposal. But in sanitary latrines, this is not happening. No one has to carry it. It is being done by some method that will be seeing that. So that sanitary latrine should be replacing the service latrines. It was decided in 1949 itself. And the sanitary latrines, it require no service. No service means no direct human service, and in which excreta can be disposed of at the site of the latrine in a hygienic manner. So I was searching for such a picture, whether that is available in the internet to show the carrying. It is unsightly. We can't even imagine. But of course, I didn't get. But this one is a book. It's a very famous book, and it had got a lot of accolades and awards also. So it is actually basically a Malayalam book, but then it is translated to English. And it's a picture like a symbol, I can say, that depicts that condition where they had to clean that toilet. They're collecting it with this broom and then the pail, and they were given a particular term in Malayalam. And this book, actually, I have not read it, but this book actually says about generation, like a father from that father, his son is taking up that job, and then to his son. So it says about the story of 2 or 3 generation, how this job was given. So that particular category of people only used to do this work, and they were considered untouchables. And yeah, Kerala is famous for untouchable in the earlier times. So if anyone is interested in reading, you will get the English version also. You can go through it. But it's a tragic story. Okay, it's It's never good. It's a tragic story. So from that, we go to the sanitary latrines. So remember, we have learned about sanitary well, and now we are going to learn about sanitary latrines. So that is non-service type. Non-service type means no human being or their direct involvement for the cleaning is coming over here. So a sanitary latrine is one which fulfill the following criteria. The excreta should not contaminate the ground or surface water. Excreta should not pollute the soil. Excreta should not be accessible to flies, rodents, animals, and other vehicles of disease transmission, which means it should be covered properly. It is not exposed. It should not create a nuisance due to odor or unsightly appearance. So, four criteria, if it is fulfilled, it is called as a sanitary latrine. No pollution of soil, water, and it shouldn't be accessible to flies, rodents, animals, etc. There shouldn't be any unsightly appearance, and also no bad odor emanating from them. So the first one is the borehole latrine. It was the forerunner or the first type of the non-service type of latrines. And this was introduced in India by the Rockefeller Foundation during 1930s in campaigns of hookworm control. So borehole latrine, from the name itself, you can understand they are going to bore in or excavate into the earth a particular hole which can be used for the toilet purpose. So this borehole latrine are most appropriate in situations where a large number of latrines must be constructed rapidly and where pits are difficult to excavate, either because of ground condition or the lack of a labor force. So in case if people are coming together for a camp and all, and we don't have the time to build a septic tank or a public sewage system, but then we have to use. So in those conditions, borehole latrines can be used. And to make this borehole latrine, a particular instrument is required, or equipment, which is called as auger. And this is more ideal if the ground condition is not favorable for pitting or the labor force is not available. In such condition, using this equipment auger, we can dug it. So this is having a particular diameter and also height, most commonly 6 meters. So this will be a borehole latrine. You can see a special this thing over there. So a particular equipment have to be used. And when the person is squatting like this and disposing, of course, this night soil, no human being have to deal it directly. It is a pit that is made up of. There is no unsightly, or it is not going to be visible, but it has got its own problem because the odor will be there. So a concrete squatting plate with a central opening and a foot rest is placed over the hole. A suitable enclosure is put up to provide privacy. For a family of 5 or 6 people, a borehole of the above description serves well for over a year. When the contents of the borehole reach within 50 centimeters of the ground level, the squatting plate is removed and the hole is closed and another one is dug. So that is the borehole latrine. The dugwell latrine or the pit latrine. So this was introduced in India in Singur or West Bengal in 1949 to 1950, around that time. It is an improvement over the borehole latrine. A circular pit of particular measurement is dug into the ground for the reception of the night soil. The advantages is we don't need a special equipment over here like the auger that is required for digging the borehole latrine. This will be of the measurements, its size will be larger. So it has got a longer life because of that larger capacity. A pit of 75 centimeter diameter and 3 to 3.5 meter deep. You don't have to learn that. It can last for about 5 years for a family of 4 to 5 persons. So the longevity of this dugwell latrine is higher when compared to the borehole. Borehole, when it can be utilized only for a year for a single family, this can be used for about 5 years. So this will be the picture of pitch latrine or a dugwell latrine. It is unsuitable where water table is high, the soil is too unstable to dig, or ground is very rocky. Then we need to go for the borehole itself, where we need that special instrument or the equipment. Otherwise, if the ground is favorable, we can go for this method. But here also we have the order problems. But then there was an improvised version for that, and it is called as ventilated improved pit latrine. So you can see a tube which is being connected over here, which acts as a method by which the air can be sucked in and it will be taken out or disposed out. So this latrine is an improved pit latrine designed to minimize odor and flies. A vent pipe which is covered with a gauge mesh or the fly proof. So the fly also won't get inside. There will be some fly proof mesh over there. So they also don't have accessibility, and the odor will be emanating out. That is incorporated. So a better variety of the pit hole. But still, this is coming under sanitary, we could say not sanitary, it is a service, non-service type, but still the problem of this odor with it's going to be a big problem. So then we have the water seal latrine. So water seal latrine is what we use, that the stool will be collected into a pit area, or that where there is a water collection, and then once we do the flushing, it is going to go out of the site, and also odor won't be there. So the water seal latrine is the further improvement in the designing of sanitary latrines for rural family. It is hand flush water seal type of latrines. Here the squatting plate is fitted with a water seal latrine. It has got two important functions. One is it prevents access to flies because of the water that is being present, and it prevents escape of odor and foul gases, and thereby eliminates the nuisance from smell. Once the latrine is flushed, night soil is no longer visible. So these merits have rendered water seal type of latrine more acceptable and also affordable to rural people than the borehole or pit privy without the water seal, because the other two didn't have that water seal, so the odor was coming up. Even the pit latrine, even you gave it a vacuum or a vent tube, but still it wouldn't have solved the problem as like a water seal. Several designs of water seal latrines have been there. One is Pride type and the RCA type, and RCA is more accepted as a suitable design. So in the water seal latrine, there is a squatting plate, and then the stool will be collected where there is actually a water seal pan, and then we flush it, it go to the collected or a storage area, the septic tank or anything. Sometimes this storage may be directly underneath this toilet system, or sometimes it may be kept in a little bit away, where there will be a tube or a pipe that is sloping towards the pit. So the water seal latrine, otherwise called as pour flush latrines, may be constructed directly above a pit. The one I told you, either this pit may be directly underneath, or it may be offset, whereby the waste travels through a discharge pipe to that pit or the septic tank. Advantages: there won't be any odor. Relatively less water is used up. It is ideal where water is used for anal cleansing and also easy to clean. Constraints: if they are going to use solid anal cleansing materials, it can cause blockage. More expensive than simple pit latrines. Then the best design that we told, the RCA latrine. In general, it may be stated that latrines of any kind should not be located within 15 meters or 50 feet from a source of water supply. When we were learning about the sanitary well, we have not studied this. Whatever be that, the toilet or the septic tank, it should be away. It shouldn't be close to that water source. It should be minimum 15 meters or 50 feet away from that water. And it should be at a lower elevation to prevent the possibility of bacterial contamination. It should be the RCA latrine. It should be provided with a squatting plate, a pan to receive the night soil, a trap, the water seal trap, which holds the water and provides the necessary water seal. There should be a connecting pipe. When the pit is dug away from the squatting plate, then there should be a pipe to connect, and that pipe will be discharging the feces to that pit. The duckbill or the pit is usually 75 centimeter in diameter and 3 to 3.5 meter deep depth and also covered. Then a superstructure will be there to provide necessary private to the person using it. So this will be the RCA latrine with the water seal, the connecting pipe, and the tank or the duckbill where the feces will be collected. Now, after this being collected, if this is a septic tank, then what is going to happen for the feces that is being collected in the septic tank? So we need to know what is happening inside a septic tank. So septic tank is usually utilized for a household, like in a small area. A single individual house of 4 or 5 people, they could have a septic tank in their house, or in small areas like if it is a village, common bathroom or a pipe that is connecting to a septic tank for 3 or 4 households, we can do like that. So here when we are using septic tank, there shouldn't be a public sewage system where there is individual home and there is space to do that. And the areas where there is no public sewage system. So septic tank is a watertight masonry tank into which household sewage is admitted for treatment. And household sewage means it is not just the soil, the night soil that we flush from the bathroom is coming. Even the water coming from the bathroom after bathing, then after washing clothes, after washing the dishes. So whatever waste that is coming, the wastewater and the night soil, everything will be collected into the septic tank. It is difficult to manage for larger populations, as I told, only for a small group of people, like individual dwellings or small group of houses and institutions. They should have adequate water supply, but they should not have access to a public sewage system. Then septic tank is ideal. The efficiency of a septic tank system is inferior to that of a public sewage, but this is much cheaper, quicker, and easier to provide and maintain than sewage works. Septic tank consists of an underground concrete tank, usually double chambered. So this will be the septic tank while constructing. And this is what inside after some usage, what we can see. There is a sludge over there, which is the solid waste, which is getting deposited, not deposited, yeah, which is getting collected on the lower part. And then the fat greasy thing that will be collected on the top, which is called as the scum. There we have in middle the wastewater. There will be an inlet pipe and then an outlet pipe also. And there should be an area between this scum or the water level to the external covering, and that should be of minimum 30 centimeter, I think. So outside it will be like this. Sometimes this also will be covered by soil. Sometimes they will be covering only a part of it so that people understand that there is a septic tank underneath and they just don't go excavate it. So the design features of the septic tank, the capacity, it varies according to the number of people, but the minimum capacity should be at least 500 gallons. The length should be twice the breadth. The depth is 1.5 to 2 meter. And out of that, the liquid depth is only 1.2 meter. So on total, the depth is 1.5 to 2 meter, but the liquid, what I told over here, the topmost, it should come only 1.2 meters. The remaining, there should be an airspace, minimum of 30 centimeter between the level of liquid and the undersurface or the cover that is covering that septic tank. There should be a minimum space, and that minimum space is because of the changes that is taking place. Because here, when the waste is being collected, of course, there are bacteria, bacterial decomposition is going to take place, and then some gas will be produced, especially methane. And for the collection of that gas is why we have to leave this particular space for the collection of that gas. And in some houses, what they do is, not all the houses, in some houses, there will be a pipe connection somehow to collect that methane, and they will be using it as for a biogas plant. Like they can use this methane for cooking purpose, especially in rural society, they do it like that. The bottom of the septic tanks will be sloping towards the inlet end. This facilitates retention of the solids. And inlet and outlet pipe should be the, which are actually submerged. There should be a cover made of concrete slab of suitable thickness and provided with a manhole. Retention period, every septic tank is designed to allow a retention period of 24 hours so that it is completely treated. The anaerobic digestion takes place. So what is the working of the septic tank? Now, before I go for working of a septic tank, did you, any one of you, did you wonder why we are studying about different types of latrines and why we are studying how a septic tank works? Did anyone of you think? No one. Oh my God. No one of you thought about it.
No. To be honest, no. No, really. But we'll
Okay.
start thinking. We'll start thinking.
Okay, I'm not going to do a mistake. Like I'm not going to ask you the working of septic tank, okay? But in India, this paper is very important. The book, the SPM book, and the working of septic tank, and also the public sewerage system, which is going to come after to it. It is an important essay actually. Important essay is for 15 marks. So we had to by heart it, and we had to write it for the exam. And when I was a BHMS student, I used to wonder why the hell we are studying all this septic tank. I never understood. But I understood it after I went to do masters in public health. At that time, I understood it is more related to the public health. So basically, why we need to learn this is the different types of latrines, especially when there is a situation. One is the main thing that we learned, that because the feces, it shouldn't be coming into contact with the like there shouldn't be any open defecation, or if it is not properly disposed, there are many diseases that is communicable, that is possible. So to put a control on it or to prevent that, we have to do. But in other manner, it's mostly when people who become MPH, usually they will be having the medical background. They are mostly any people is open towards the course MPH, but mostly it will be the people from the medical field going for MPH. So in case they are working in future as a public health manager, and mostly this will be coming into use when you become a public health manager and you have to uh, manage an area where a large number of people have been coming together or living like in a camp, like a refugee camp in a area of crisis, where some climatic situations has happened and a lot of people have congregated in one section or one area, and you are becoming the public health manager of that area. You need to know how to dispose the waste, because a lot of people have been living in, will be living in that area for 1 week or something, and there is no time to build a septic tank or proper latrine. So at that time you need to know the different options that is possible and what are the advantage and non disadvantages of each one. So that is why we learn different types of latrines. Mainly what will be used will be the, in case of crisis, the refugee camps and all. Refugee camps only if it is for a short term. If it is a longer term, we have to go according to that. The number of people, then do the necessary things, the septic tank or whatever we have to do. But if it is for a shorter term, then the pit latrine or the borehole latrine, depending upon the ground that is the. So that is one purpose in case you become a public health manager of a particular area, camp like this. Then another one could be there is a separate section which is coming under public health engineering. So in case you are becoming a researcher, an engineer there is that field, the engineer people will be going for there is a particular name for that field of engineering also. Public health engineering is there, but some other term is also there. Like they will go for the buildings. This much size window should be the then the ventilation should be of this much size. The air should be coming from this direction, so this should be placed in a particular direction, like that. So the engineers can say like the architectural way, where and how and what size should it be placed. But what are the benefits of it, or the health-wise benefits, or the health-wise risk of it if it is not properly placed? That only the doctors or the people in the health field will be knowing. So sometimes when it comes, we may have to work together in research or any practical oriented works where we have to work with the engineers. So maybe they will do the calculations, all these things, but the health related things that we have to suggest. So for a collaboration, at least we should know when the person is saying about the septic tank, we should have this much centimeter, this much size. The people, because the public health engineers are mostly coming from the medical background, they should have at least a basic idea when the person is saying, even if not the centimeters or the measurements or the depth, what is the purpose, what is happening when the night soil is collected in a septic tank, how we can dispose it. We should know at least a basic of that. So even if, because I'm not going to ask this question, I don't want you to study by heart. There's no meaning in studying by heart, but at least that basic principle, the process that is happening, at least that you should know. So that is the purpose why we are learning about these latrines. So now going back to the working, what is happening inside a septic tank. So the solid will settle down in that tank, the fecal matter, whatever, that will be settling down, and that is called as the sludge. While the lighter solid, including the grease and fat, it rises to the surface to form the scum. I hope you remember the earlier picture. The solids will be attacked by the anaerobic bacteria. Actually, when a new house is constructed, like in my place in Kochi, because we do have, like what I was saying, we do have individual house, the wells also, and like that individual house they will be having, they have to keep this septic tank. Only then we get the sanction from the municipality or the corporation to build the house. Only when we show the septic tank and its position, so they will see whether it is that much centimeter or meter away from the nearest what well, whatever, and then only they will give the sanction to build the house. So this septic tank, when they after the construction of the septic tank, there is a need of sludge that is required, which the people will be taking from some other formed septic tanks. Like the septic tank has to be cleaned annually, depending upon the usage, and then that sludge they will be drying it, and this sludge they will bring it somehow. We don't have to bother the people who are constructing this septic tank. Once they finish with this masonry work, the concrete work, they will be bringing that initial sludge from some other area and they will be laying it over, because it needs bacteria for the organic matter to be decomposed. They need that bacteria, so the sludge they will bring from somewhere. Even our house was newly constructed, like maybe 3 years back or 3 or 4 years back. But even I don't know how, from where did they bring. I just know after 2 days of construction, they made it to dry and then they brought the sludge and then they covered the septic tank. So this sludge, because that sludge will be having the anaerobic bacteria and also fungi. So not the term anaerobic. So here, like the composting that we learned, the tipping, here also anaerobic process is going to take place without the usage of oxygen. And this bacteria will be breaking down the organic matter, the solids, into simple chemical compounds. So this is the first stage of purification, and that is anaerobic digestion. Now what I colored over here, at least that you have to remember, because that comes for the MCQ. So in case of septic tank, the first process, the first purification that is happening is anaerobic one, and that is happening inside the septic tank. The sludge is much reduced in volume by as a result of this anaerobic digestion, and then it is rendered stable and also inoffensive. And during this process, a portion of the solid is transferred into liquids and gases. And that gas mainly will be methane, which I told in case of small households, they will be using it for biogas or to use it as a fuel in the households for cooking purposes. Or otherwise, these gases will be rising in the form of bubbles. The liquid which passes out of the outlet pipe from time to time is called as the effluent. And this effluent, it will be containing numerous bacteria, cyst, helminthic ova, organic matter in solution or fine suspension. So there is an outlet pipe through which that water is coming out, the liquid is coming out, and this will be having so many bacteria, cyst and helminthic. And this outlet pipe, this will be percolating into the subsoil or the soil just underneath, and there are millions of aerobic bacteria in those layers of the soil. And this bacteria, the aerobic bacteria, will attack the organic matter which is present in the effluent. As a result, the organic matter is oxidized into stable products like nitrates, carbon dioxide, and water. And this stage of purification, that's the second stage of purification, and that is aerobic oxidation. So in case of a septic tank, when the fecal matter reaches over there, the solid part, it will be getting accumulated in the ground area or the floor area. Then there will be water in between, which will be collected, and the greasy material in the top layer. So that the greasy material or the fatty matter, we call it as scum, and the underneath low-lying that solid thing, we call it as sludge. And that sludge, it will be acted upon by the anaerobic bacteria which is present inside the septic tank, and it will be making it into or reducing its volume and also making it stable, inoffensive. Then as a result of those chemical reactions, liquid and gases will be coming upon. The liquid that comes up, it will be taken out by the outlet pipe and it will be percolating to the soil. And in the soil, what happens is actually the aerobic oxidation or the aerobic oxidation is taking place, which is the second purification that is happening. And when this aerobic bacteria act into it, all the bacteria, the cyst, helminthic ova, everything is going to get destroyed, and that will be converted into a stable matter which is having nitrate, carbon dioxide, and water. And that is comparatively safe. That soil, it itself acts as a good manure where we can plant our trees. But on all this septic tanks, the outlet pipe is not like that. Sometimes the outlet pipe will not be opening towards the soil area. Sometimes the outlet pipe will be inside the septic tank itself. This takes place within the second chamber of the septic tank. It depends upon how the septic tank is built. Like here we have told that ideally the septic tank should have, what did I say? The septic tank should have actually two chambers. So this is like a two chamber. So here itself the aerobic will happen. In case if it is two chamber, then the outlet pipe is not allowing the effluent to go to the soil. The treatment is taking place over here. But in this one, there is only a single chamber. So in this single chamber, the outlet pipe, it takes the water to the subsoil level where the organic aerobic bacteria will act upon and do the second part of the digestion. So usually if we consider that the septic tank is single chambered, what is happening is the first step, the purification, that is anaerobic one, which is happening inside the septic tank. And the second process is aerobic one, which is happening outside the septic tank on underneath the soil. Only that much you have to remember. So to sum up, two stages are involved in the purification of sewage. The first stage is anaerobic digestion taking place inside the septic tank proper. And the second stage is aerobic oxidation that is taking place in the subsoil. Now about the operation and maintenance, it is very simple. To commission a septic tank, it has to be first filled with water and then seeded with a bucket full of sludge from another tank. We have to bring it from another tank, as I told, because that will be having that anaerobic bacteria. The use of soap water and disinfectants such as phenol should be avoided as they are injurious to the bacterial flora in the septic tank. Not directly using the soap water and disinfectant. Undue accumulation of the sludge, it reduces the capacity of the septic tank. So every year, or depending upon the usage and the number of the people and also the capacity of the septic tank, we should do the process of desludging, or we should bail out the contents in the septic tank once in a year. The bailed out sludge is then disposed of by trenching. So usually this process takes place at night, okay? Night, there are people actually in Kerala and also in India, wherever the septic tank is being used. There will be people to do this work, a modern type, but they are not coming into contact with the soil, night soil in any way. They will be coming with a particular van and at night, midnight actually, and they will be a pipe will be the larger size pipe, something that can pump in the air and take the contents actually, a pressure kind of thing, and they will be laying it from the van to the septic tank. So when the septic tank is constructed, they construct in such a manner that this can be desludged. So they will come and these people know where are those things. We don't have to be there. And then they will put the that pipe, which will be very wide, okay, into that septic tank. And then they operate by the motor and the contents will be by pressure, it will be sucked in to the tank. So the people are also not coming into contact with the night soil. And after once it is cleaned, it is evacuated. The people again will cover that septic tank, that particular area. They will cement it off and then they will go. So once every year depending upon the usage and the capacity of that septic tank, we have to do this process of desludging. And once it is taken out, it is disposed of by trenching. And now you would be understanding when we told the process of composting, and I told you the night soil will be mixed into it. So the current day night soil, earlier the night soil, what they meant would be the direct human excreta when it was the service type. But nowadays, it is actually this the sludge that is coming out that is being mixed and then for the process of composting. We have the chemical toilets, especially that is used in, isn't it? Yeah, used in aircraft or trains. So chemical toilets are sanitation units that consist of a squatting pan placed above a watertight excreta holding tank, which usually contain a chemical solution, formaldehyde, etc., to aid digestion and to reduce odor. So this is temporary type, where pit latrines of septic tanks are unsuitable, especially in aircrafts or trains. So the initial charge of chemicals is adequate for 40 to 160 users, so maybe one trip. They're used in aircrafts as a short-term measure as a short-term measure in disasters. Advantages: it is portable, hygienic, minimized odor, can be mobilized rapidly, and constraint: it is high cost, unsustainable for longer period, regular servicing and emptying is required. Now, the disposal of sewage. So the people, in case now it is a bigger city where there is a public sewage system, what is happening with the sewage? In a single household, we learned how it is being desludged and then removed. But what happens in a city like Kuala Lumpur? How it is happening? So what is sewage? We start from that. Sewage is wastewater from a community containing solid and liquid excreta. This we have already learned in one of the earlier slides, the difference between sewage and sullage, and that is actually an MCQ question. So if it is the wastewater plus night soil, it is called as the sewage. And if it is only the domestic usage water or the water or the night soil or the fecal matter is not there, then it is called as the sullage, which is the wastewater from kitchen and bathroom. The amount of sewage that flows into the sewers depend upon habit of the people. If people use more water, there will be obviously more sewage. Then time of the day. So usually it will be morning when the people will be utilizing the bathrooms more, the toilets more. So the amount of sewage that is coming will be higher in morning, and towards afternoon, the flow is going to lessen. And again, there is a slight increase in the evening or night. The average amount of sewage which flows through the sewerage system in 24 hours is called the dry weather flow. This could be asked as a MCQ. We go to the public sewerage system or the water carriage system. The water carriage system or sewerage system, it implies collecting and transporting human excreta and wastewater from residential, commercial, and industrial areas by a network of underground pipes called sewers to the place of ultimate disposal. It is the method of choice for collecting and transporting sewage from cities and towns where population density is high. Laying down such a system is much capital intensive because it is going to cost a lot. It amounts to digging up lanes and by lanes. Skilled manpower is required. Piped water supply is mandatory. Ongoing maintenance is required. But this is the ideal system of sewage disposal in cities which are larger or with high population density. So this will be the public sewerage system, where there will be underground pipes, the sewage thing, and the sludge after the treatment. Then they will be used for the composting or the control tipping. And then composition of sewage, it's mostly water, 99.9% of water. The solid will be barely 0.1% and partly organic and partly inorganic. So why we do the sewage purification? If you are going to put the sewage directly into the sea or to the river, it is going to cause water pollution and that will result many diseases. But another important thing is, now in the previous slides, last class, we learned about the biochemical oxygen demand. So in biochemical oxygen demand, what we learned is when we are going to put this waste in the river water, the bacteria over there, it is going to utilize the oxygen and then they are going to break down the waste materials. So if the waste material is not treated properly, or we are going to send the sewage without any treatment directly to the water, the organism, the bacteria inside the water, anyway, it will break it down. You don't have to worry. They will break it down. If it is not plastic, the organic matter, they are going to break it down, but they are going to utilize more of oxygen. And if they are going to utilize more oxygen, then there won't be oxygen for the flora and fauna in the water. And that is going to kill the flora and fauna in the water. And also it can result in the water pollution. So in a longer term, we can't do this. But the main purpose is we will make this sewage into a stable content so that the bacteria doesn't have to utilize much oxygen for its further decomposition. So that's the basic idea for the treatment of the sewage. So raw sewage or inadequately treated sewage, it should not be directly discharged into rivers, sea, or other sources of water supply. This is because the oxygen in the water supply is used up by the numerous aerobic bacteria found in the sewage. The depletion of oxygen may lead to the death of the plant and animal life in water. Furthermore, the water may yield an offensive smell because of the release of hydrogen sulfide. So the aim of sewage treatment is to stabilize that organic matter so that it can be disposed of safely. So how to know whether the sewage has been enough stabilized or not? We use the indicator, the biochemical oxygen demand. So biochemical oxygen demand is defined as the amount of oxygen absorbed by a sample of sewage during a specified period, generally 5 days, at a specified temperature, generally 20 degrees Celsius for its breakage. So if the biochemical oxygen demand or BOD value is higher, it means that much oxygen has been taken and that is not good. It is not, which means that the waste or the sewage has not been properly treated, or it is very strong and it is a big pollutant to the water. So BOD value ranges from 1 milligram per liter for natural waters to about 300 milligram per liter for untreated domestic sewage. So you can see if it is a natural water which is not polluted, BOD is just 1 milligram per liter, whereas if it is untreated sewage, it is 300 milligram per liter. So as the BOD is going higher, means oxygen is that much getting depleted. So we need to stabilize the waste so that the oxygen utilization is reduced, or in other way, BOD is reduced. That should be our aim. If the BOD is 300 milligram per liter or above, the sewage is said to be strong, or it requires that much oxygen for its breakdown. If it is 100 milligram per liter, it is said to be weak. So our aim of treatment, the sewage treatment, is always to make it lower, the BOD level to be lower, so that now it is very safe to be disposed to the river or even seawater. Seawater ideally. So the type of sewage system, we have the combined system and the separate system. In combined system, the sewage and the storm water comes in the same sewage line. The sewage means the water that is coming from the individual households, that will be the sewage water, and the storm water, like when the rain happened, the running water, that also. So that when both comes in the same pipe, we call it as a combined system. And if it is two different pipes, the surface water, the running of water, the rainwater is not admitted into the sewers. It is called as the separate system. I didn't keep the picture. Sorry, I forgot to keep that picture. So the components of a public sewerage, it starts with the household. Okay, from the household it starts, because if you remember the picture that we had already, this one, the in the seaward area, we are actually starting the infrastructure, the thing that is used in individual household. From there itself, the components are starting. It starts with the household sanitary fittings, which include the water closet, urinal, wash basin, bathtubs, etc. There will be underlined pipe, the soil pipes, which carry excreta from the water closet to the house drain. There will be house drain, which is underground, either iron or stoneware pipe, and this will be carrying the household sanitary fittings to the street sewers. Then we have the public sewer, carriage of sewage from domestic, industrial, and commercial area to the place of final disposal. And finally, some sewer appurtenances, which include manhole and trap. Manhole are the places where the man can get into the sewage system for some repairing or cleaning. The manholes are usually placed wherever there is a change in direction of sewers, at the junction of two or more sewers, and at a distance of 100 meters in the long straight run of the sewers. So manholes are usually created at three places whenever there is a direction change of the sewer, or at a junction where two or three sewers are coming together. Now at a distance, if it is a long running or a straight one, at every 100 meter, there will be a manhole. And the main purpose is actually to do some repairing, cleaning, etc. Workers entering manhole are at a risk of gas poisoning and asphyxiation, so due precautions should be taken while entering into them. Then there will be another one, another appurtenance, that is the trap. And the trap is actually to prevent the entry of foul gases inside the house, and also to remove sand, grit, grease, etc. from sewage. Like, because it is a public sewage system, any any pipe is getting damaged means that smell can come to individual houses. So even that has to be prevented. So that is why they use the traps, and traps are also placed at 3 points. Like the manhole, mainly placed at 3 points, the traps are also placed at 3 points. Under the water closet of that individual toilet, at the junction of the house drain and the street sewer, and where the surface water enters the sewers, if it is actually a combined system. So you should know the manhole. The purpose of manhole is for repairing and cleaning. The use of trap to prevent the entry of the foul gases. And you should also remember in which areas these manholes are kept, and also the areas at which traps are kept. Then after it reaches the sewage area, the treatment. Here also the purification is brought by the action of anaerobic and aerobic bacteria, like what we saw in the septic tank, anaerobic and aerobic. That's the same thing happening over here. So this is divided into two stages, primary treatment and secondary treatment. In primary treatment, like in the septic tank, the effluent is subjected to anaerobic digestion, and in secondary treatment, it is subjected to aerobic oxidation. So this will be a chart which shows the functioning, the sewage coming in. There will be a screen so that the larger things will be kept or it will be screened out. Then there will be a grit chamber where the sand grit larger in size get deposited. A primary sedimentation tank where the anaerobic action takes place. Then it's biological treatment. The final sedimentation tank, and then the effluent is disposed. Before to that, chlorine is also used so that the treatment is done. Then the sludge will be taken to the sludge digester where the gas can come out, methane gas. Then there is sludge drying beds, etc. So this is actually the complete flow chart, what is happening in a public sewage system, what is happening with that sewage treatment, the different steps that is happening. And this one we will be watching 15 minutes more other. I don't know what is the timing for this duration for this video, but we'll see that because it explains that process.
Cities and towns have sewerage systems in place to carry the wastewater from our homes, hotels, factories, and other establishments to a sewerage treatment plant where the wastewater is treated. It is then deemed safe to release into other water sources. The treatment of wastewater goes through different stages. Wastewater is treated to remove the physical, chemical, and biological contaminants present in it through various processes. The pre-treatment process involves the sewage being sent through grids or vertical bars that can remove large solid substances like metal cans, paper, and plastic materials. In primary treatment process, the sewage flows through the grit chamber very slowly, so that the sand, pebbles, and soil settle down at the bottom. The sewage flows into the settling tank or sedimentation tank, where the solid wastes like feces are allowed to settle down. Wastes such as soaps, oils, and grease rise to the top of the wastewater. The waste material that settles down at the bottom is called the sludge, and the floatable material is called the scum. Scum is then removed using a skimmer, and sludge is removed with a scraper every few days. The water that is left out is called the clarified water. In the secondary treatment process, biological or organic wastes are removed. It is a biological process. This is done by transferring the clarified water into an aeration tank, where air blowers bubble air, which helps the aerobic bacteria to grow and feed on the organic contaminants such as food waste, feces, and other organisms. The mixture then flows from the aeration tank into the clarifier, where activated sludge settles out by gravity. The activated sludge so produced, along with the sludge produced in the primary process, is transferred to the digester, where it is decomposed by anaerobic bacteria. Biogas is produced in this process, which can be used as fuel or can be used to produce electricity. The activated sludge is then left in the sand drying beds. Some quantity of water in the activated sludge evaporates and the remaining quantity drains through the sand beds. This leaves behind the remaining dried sludge, which can be used for making fertilizers or compost. In the tertiary treatment process, the leftover wastewater is treated with chlorine to remove the phosphorus compounds, nitrogen compounds, and bacteria. It is a chemical process. Chlorine tablets are added to kill the germs. This process is called chlorination. Then this water is let off into the water bodies.
So that is the basic principle happening inside, in a public sewage system. So you saw that both the aerobic and anaerobic oxidation is taking place, the purification. So what the final outcome is that sludge, it is now safe to be disposed into any water, especially seawater. And then it will be gradually getting decomposed, or we can use it as a compost for the manure purpose. So that is the process of sewage treatment to make it a stable one, which is not dangerous even on exposure. So the disposal of the effluent, the final one, it can be disposed into rivers and streams, and that is called as disposal by dilution, or it can be even disposed on land, wherever the suitable land is available for irrigation purpose. Now, disposal of the deceased man and animals. I didn't go into detail because these methods you know. We have the legal and less common legal method for the disposal of the deceased. Legal method is ground burial, and the other one is cremation, where you're going to burn the body, the dead body. The less common legal method is composting. In some countries, some people, they voluntarily ready to do that. I have read something like that. Then burial at sea. Now, this can be actually like the Hindu religion, they follow after the cremation, the ashes, a little bit of the ashes, it will be thrown into the sea, or it can be the whole body that is being disposed. And it can be even ship burial like a voyage that is happening. And in near future, if they are not going to anchor in a nearby seashore or a port, if there is no facility to store that dead body, then they don't have any other option than to throw the body to the water. So these are the methods by which the dead body of the man or animals are being done. So in conclusion, the solid waste disposal can be done by these methods: dumping, control tipping, incineration, composting, and manure pits. And we have to do the disposal of excreta in an effective and hygienic manner. In the areas without sewage system, we can go for pit latrines or borehole, or even the pore flush or the water seal latrines. The trench latrines are usually used for camps of shorter duration. Septic tank is a suitable method for final disposal of the night soil in case of small number of households. Water carriage system is the ideal system for the sewage disposal, especially in the city areas or where the population density is very high. So this was taken from the PPT of some Dr. Navpreet, professor at Government Medical College, Chandigarh. I just felt it very good. So can we just do that? Large city, which will be the ideal one. Come on, open your cameras and give me the answer. Not camera, sorry, your voice system. Sami, are you all hearing me? Where we can use this large city, which will be the ideal latrine or thing that we can use? Am I audible?
Yes, Miss, you sound clear now.
Yeah, so which will be the ideal method in case of a large city? Okay, then we go to the second question. Group of 20 households. None of you were attending the class. Temporary camp, family in a town. Okay, fine. Don't. I guess you were not attending the class. None of this you are able to answer means I don't know what to say. So expect the unexpected question from this PPT for the exam. Okay, that's all I can do. Okay, this was about the waste processing in Singapore. You can watch it later. The incineration process that they do. References. Thank you. That's all for today. So we'll see in the afternoon. And because you have not answered, I'm going to put difficult question. Okay, I may even put the working of a septic tank or even the public sewage system. Study for the exam. So okay, thank you. Afternoon, I get put the time 2:30. We'll join for material medical that time. Okay.
Okay, thank you. Bye.
Okay.